Now let's do terms related to lenses. First, center of curvature. A lens has two spherical surfaces. You have understood now that the lens is made by joining two parts of a sphere. Each of these surfaces forms a part of a sphere, right? So, the centers of these spheres are called centers of curvature of the lens. So, what is center of curvature? The center of the sphere of which the um, lens is a part. The center of curvature of lens is usually represented by letter C. Since there are two centers of curvature, we may represent them as C1 and C2. To distinguish between the two, we can say they are represented as C1 and C2. So here in this diagram, you can see that this is a convex lens. So this part of the lens is of this spherical sphere, isn't it? And is given, the center is given a term C2, and this part of the lens is part of this sphere. So here we have given it a name C1. Similarly, this concave lens, this part is belonging to this part of a sphere. So here there is one center C2 and this part is part of another sphere. So this is center C1. Radius of curvature. The radius of a sphere of which lens is a part is radius of curvature. Now here you can see a convex lens. So now over here you can see that convex lens is part of this sphere. So this radius is known as radius of curvature. Here also we have shown you the radius curvature but of the other part of the lens, right? And here you can see the radius curvature of concave lens. So one part of the concave lens is on this side, other on this side. So it is very nicely shown in a single diagram. So here you can represent it one as C1 and the other will be C2. So this is the radius of curvature. This is another radius of curvature. Optical center. The central part of the lens is its optical center. So this line we had said was an axis, principal axis we had defined earlier. There's the right. Now here the middle, this is absolutely the middle of the lens, right? This middle of the lens is known as optical center. It is usually represented by O. Principal axis, the straight line that goes to the center of the lens at right angles to the lens surface. So now you have two terms. One is the principal axis that is passing straight to the center of the lens and it is obviously right angle to the lens. And another is the optical center which is exactly the middle. So basically a principal axis will pass through the center of curvatures of the lens and the optical center. Now, optical center is also a point. It can be defined as a point through which the light passes undeviated, right? So, an optical center, you can not only say is the middle of the lens, right? You can also say that it is a point on the principal axis of a thin lens through which light ray passes undeviated. Aperture of a lens. It is the effective diameter of its light transmitting area, the brightness, that is, the intensity of the image formed by the lens, which depends on the amount of light passing through the lens, will vary as the square of the aperture of the lens. So here there is a lens and you can see that from one end of the lens to the other end of the lens, what is this? This is going to be the aperture, the entire length of the lens through which light can pass. Focus. When light rays parallel to the principal axis get refracted by the convex lens, they converge to a point on principal axis. This point is called principal focus. You had already seen that with light rays parallel to the principal axis, they were going and meeting at a point. They were converging to a point. That is known as principal focus. When rays parallel to principal axis get refracted by concave lens, they appear to diverge from a point on the principal axis, which is known as principal focus. So you had even seen the diverging action of the lens, and you had seen that all the rays were appearing to diverge from a point which will be known as focus. So here this is the focus, right? And here this is the focus. If parallel rays pass from opposite side of lens, another principal focus on the opposite side is there. Remember, a lens has two principal focus, which we usually name them as f1 and f2. Now, we have both the focuses over here. Now see, when you consider this as first principal focus is the point on the principal axis of a lens at which if an object is placed, the image will be formed at infinity, right? We'll come to know how the image is formed at infinity later on, but this is a point from where the light rays, when they fall on the lens, they will become parallel to the principal axis. So this becomes the first principal focus. Here you can see the rays which are coming, and they are going to go and appear to come from this point. So this becomes the first focus. Second principal focus is the point on the principal axis of the lens at which the image is formed when the object is at infinity. Now here the light rays are coming parallel, so that means they are coming from some infinity. They're meeting at this point, so this becomes f2. So here also the parallel rays are coming and they diverge and they appear to come from this point, right? So remember, there are two surfaces, so obviously two centers of curvature, two radius of curvature, and there will be two focus also, one on either side of the lens.